In the second part of this lecture, we're going to continue discussing DevOps. The focus of DevOps is the development of an application software and support software. The essence of the DevOps is that all participants in creating a product or system should collaborate from the beginning. Most application vendors and in-house application developers typically follow 4 stages in the development and deployment of applications. They are development, system integration testing, user acceptance testing, and production. Agile development emphasizes teamwork, customer involvement, and most significantly, the creation of small or partial pieces of the total system that are tested in the user environment. It has proven to be more effective for dealing with the changing requirements that tend to occur during the development phase. Agile development is characterized by frequent releases in an iterated loop fashion with a certain amount of automation in the form of tools that can be used to support collaboration. DevOps takes this philosophy much further. It is characterized by rapid releases, feedback loops embedded throughout the process, and a comprehensive set of tools and documented best practices to automate the DevOps process. DevOps is reviewed as a repetitive cycle of 4 major activities, including plan and measure, develop and test, release and deploy, and monitor and optimize. It is intended to improve the efficiency and effectiveness of the process of managing applications throughout their life cycles. Fundamentally, DevOps rests on 2 key foundations: collaboration and automation. Collaboration begins with the management policy to encourage and require the various actors in the software development and deployment process to work together. The automation consists of tools that support the collaboration and are designed to automate as much as possible the cyclic process. Next, we're going to introduce incorporating security into the system development lifecycle. The enterprise security considerations dictate that security-focused activities and deliverables should be a part of every phase of the system development lifecycle to ensure that the developed system is able to withstand malicious attacks. The National Institute of Standards and Technology special publication lists several benefits of integrating security into the lifecycle. First of all, it enables early identification and mitigation of security vulnerabilities and misconfigurations, and it results in lower costs of security control implementation and vulnerability mitigation. Second of all, it enhances awareness of potential engineering challenges caused by mandatory security controls. Third of all, it assists the identification of shared security services and reuse of security strategies and tools to reduce development costs and schedule while improving security posture through proven methods and techniques. And fourth of all, it realizes the facilitation of informed executive decision-making through the application of comprehensive risk management in a timely manner. And the fifth benefit is that it allows the documentation of important security decisions made during development, and ensures management that security was fully considered during all the phases. And the sixth benefit is that it leads to improved organization and customer confidence to facilitate adoption and use, as well as improved confidence in the continued investment in system development. Finally, it results in improved system interoperability and integration that would be difficult to achieve if security were considered separately at various system levels. In addition, the National Institute of Standards and Technology's special publication provides the following elements in defining the security considerations applied during each phase. The first element here is the major security activities. During each phase, a number of security-related activities are needed to ensure that security is incorporated effectively in the design phase. Another element is expected outputs. A key of success in incorporating security is to define specific deliverables for each activity. And the third element is synchronization. A feedback loop between tasks provides opportunities to ensure that the system development lifecycle is implemented as a flexible approach that allows for appropriate and consistent communication and the adaptation of tasks and deliverables as the system is developed. The final element here is control gates. Control gates are decision points at the end of each phase, which the system is evaluated and when management determines whether the project should continue, change direction, or be discontinued. The flowchart here on this slide shows all the elements of security considerations applied during each phase of the system development lifecycle defined by the National Institute of Standards and Technologies. And finally, we're going to introduce system development management. It involves planning, delivering, operating, supporting, and evaluating the system development lifecycle. Therefore, system development management is an overall high-level supervision of the system development through all the phases of the lifecycle. The International Foundation for Information Technology lists the following as functions of system development management. The foundation for effective system development management is the adoption of a system development lifecycle methodology to be used on all system development projects. It is important to document the steps and deliverables of the system development lifecycle and to assign roles and responsibilities. The International Foundation for Information Technology lists the following principles or best practices for managing the lifecycle. And the next element of the system development management we're going to discuss is the system development environment. As systems evolve within and throughout the different phases of the lifecycle, the systems are constructed, verified, and promoted from one working location to the other, and the IT industry calls that location environment. The International Foundation for Information Technology lists the distinct type of environments associated with system development, including research, developer workspace, centralized build, integration testing, user acceptance testing, and production. The system development environment requires both the security of the system itself and the security of the enterprise that exists outside of the environment. The security objectives for the environment are twofold. First of all, the system owner should ensure that nothing outside the environment will contaminate or corrupt the environment in a manner that will prevent it from functioning. This is essentially a denial of service issue. Second of all, the system owner needs to ensure that no malware or other functional feature is introduced into the system during the development and may later be used maliciously in the operation environment. With respect to the security of the enterprise, the system owner needs to ensure that nothing inside the specific environment escapes and is shared with the resources or systems that operate in other environments without specific knowledge or approval. Both of these aspects of environment security require to address a number of key security areas, including environment access security, environment role and responsibility security, and environment data and information security. So the last element we're going to introduce about the system development management is quality assurance, which deals with assessing compliance with requirements and standards. Many companies have a separate department devoted to quality assurance. A quality assurance system is set to increase customer confidence and a company's credibility to improve work processes and efficiency and to enable a company to better compete with others. Quality assurance systems emphasize catching defects before they get into the final product. Important security-related quality assurance tasks for the system development include assessing development risks, ensuring that security requirements have been clearly defined, confirming that security controls agreed upon during the information risk assessment process have been developed and are working correctly, confirming that individuals responsible for developing, testing, and implementing systems under development are following the methodology.